Solving linear functions is what we're going to, or linear equations is what we're going to be looking at doing in this case here. So when we talk about that, solving linear equations can be thought of in two different ways. Okay, so it can be thought of in two different ways. The first one, number one, is that if we are given a certain input, okay, and so this is going to be what we would consider to be x. X is going to be our input that we're going to be given. What does the output look like? Okay, and so that's going to be y. Now, when I say that, it's usually because x is going to usually have some other operations being done to it. Y is going to usually be done by or all by itself. Okay, and that's the way that we're at least going to put it in this case here. The input is going to have some operations to do to it. The output is going to be by itself. In that case, it's going to be y. Now, the second way of solving it, and this is what we're going to be looking at a lot in this class here, or in this lesson, is that based on our output, the output given, so let's say we know the output array, we know what y is, what input, okay, so that is our x. So if we know what our y is, what input is needed to complete the statement? Complete. Oh. So if we know the output already, what is the input that's needed? Okay, and that's what we're going to be really looking at in this class, in this lesson, as to can we come up with that input value. Now, an equation can be solved using order of operations, as we've done in the past. Okay, if one side is completely full. What I mean by saying this is that if we know everything on one side and we want to try to find the answer, okay, so very much what we've done a lot this year is, order of operations, solving for a side. If one side is completely filled, no variables, we can solve it to find the other side. We can find that missing answer. If part of a side is missing, okay, so there's a variable there, so there's an x or a y there, in the case that we're going to look at least now, then the opposite order of operations must be followed to solve for the missing variable. So what we're going to be doing is we're kind of going to be doing order of operations backward. So what that means then, okay, is that to solve, backwards, okay, so solving for a non-isolated variable, okay, the opposite operations need to be done to both sides. And I'll show you what that means in just a minute here. Okay, so it needs to be done to both sides of the operation. So here we have an example. We know that x plus 13 is equal to 19. What that means is that we're trying to figure out what value of x is going to give us 19. We can think of 19 as being our y value. Okay, so we think of that, or that is our output value. Our input value is this x value. So what input do we need to put in here to get 19 as our answer, 19 as our output? Okay. What we're going to be doing is we're going to need to do the opposite of what's going on here to get x all by itself. What we're trying to do is we're trying to isolate x. Okay, and that's the key. We're trying to isolate x, we're trying to get x all by itself. So the opposite operation of adding is subtracting. Okay, so the opposite operation of adding is subtracting. So we're going to be doing the opposite. So in this case here, you'll notice how we have our x value and we're adding 13 to it. Okay, so we have our x value, we're adding 13 to it. The opposite of adding 13 is subtracting 13. So that means that 13 needs to be subtracted from both sides. Okay, and why does this work? Well, the goal, I call it the golden rule of math, and it kind of plays off the golden rule in general. Do unto others as you would have them do to you. That's what is often considered to be the golden rule. The golden rule of math is do to one side as you would do to the other. So whatever, if we want to keep things equal, we need to make sure that we always do the same thing. So if the same thing is done to both sides of our equation, then the value of the total equation does not change. Okay, so if we do the same thing to both sides, the total value doesn't change. Okay, let's think of it like a balance scale. You might have used balance scales back in science class back in the day. Okay, if you were to take off a weight on both sides, the scale stays balanced. An equation is exactly the same way. Okay, so if like a balance scale which has the same thing done to keep it even, okay, or keep it level, I think is the word that I was going to use here. There we go, to keep it level. So in this case here, if we are to subtract 2 from both sides, sorry, not subtract 2, subtract 13 from both sides, and I'm going to do this with, so let's say that here we subtract 13 from this side, okay, and here we subtract 13 from this side. Okay, that's supposed to be a 13, not a, let's make that a little different. There we go, there's a 13. When we do this here, if we were to add 13 and then subtract 13, it cancels out. It actually makes it into 0. Okay, so what that's going to give us then is that will mean that on this one side here, all we have left is x. And if we get rid of the 13, we're subtracted away, we get all we're left with is just x. On the other side, if we do 19 minus 13, those are both numbers, so we can solve it, and that would be 6. So it tells us that x must be 6. Okay, x must be 6. Now, I'm going to explain this a little bit later. I'll put it in there. But if we put this, put 6 back in for x, okay, so let's say we'd have 6 plus 13, it equals 19. We know that that works. That means that this is, in fact, correct. Okay, this one is, in fact, the right value that we need. We double-checked our work. We figured out that it does, in fact, work. Okay, so that's if we have adding in there. If there's subtracting, okay, x minus 2 is equal to 16. Well, what value of x do we need in there? Well, the opposite of subtracting is adding, okay? And if we add 2 to both sides, then we're going to get the x is now going to be isolated. Okay, so the x is going to be isolated. And that's really what we want to do here. We're trying to isolate the x, okay, and get it all by itself. But here we're subtracting 2. So then what we need to do is add 2 to both sides. And so I'm going to draw that in here. Again, I'm going to do my best here. So let's say that we add 2 to this side. What we need to do is we also have to add 2 onto this side. Okay, we have to add to this side. These ones are going to cancel out because negative 2 plus 2 is just 0. Okay, negative 2 plus 2 is just 0. And so then when we solve it, we're going to have x on this side all by itself. So that's talking about isolating it. And we're going to be told that x is going to be equal to 18 because 16 plus 2 is 18. Okay, so that's what we talk about when we talk about isolating a variable. We're getting it all by itself. Now, as I mentioned before, I'm going to put it into words here to verify that the value is correct. So to verify that we found the right one, let's put the answer for x back into the equation and make sure that it works out. Okay, so I'm just going to put that in down here. I'm going to verify it down here. So if we put in 18, so we found the x was 18. So if we put 18 in for x, at that 18 minus 2 is equal to 16. Well, that is what we had there originally. So that means that it must work. Okay, so it in fact does work. Let's do a couple of examples just to show kind of, again, how this works. Okay, x plus 5 equals 14. For adding 5, we want to get rid of it, so the opposite is to subtract 5 from both sides. Okay, and if we subtract 5 from both sides, then this first side is just going to be x all by itself, and the second side is 14. It would be 14 minus 5. Okay, so that's what we could think of it as, 14 minus 5. We can solve this. Okay, we know that x has to then be 9, and 9 plus 5 is 14. In the same case here on the with our next one, okay, we have x minus 12, so the opposite of multiplying, or sorry, subtracting is adding, so we're going to add 12 to both sides. And again, whatever we do to one side, we have to do to the other. And when we solve for that, okay, x minus 12 plus 12, we're just kind of adding it on. And again, if we do the same thing to both sides, it doesn't actually change our equation at all. This is just going to be x on one side, so they'll cancel out. And 45 plus 12 is 57. So our x value would have to be 57. 57 minus 12 is equal to 45.